All right, let's see if we can get through chapter 5 here in 5 minutes. Obviously, things in the final will be big, huge, important topics, not little small things like area of sector, area of arc, or whatnot, but big takeaways from this course this year. So I kind of went through the final, picked out the the 4 kind of questions you're going to see. Here are your 4 important topics: converting, the 6 trig functions, how we made the unit circle, and how we did our trig graphs. So quickly here, this is how we convert. We know a circle is 360, so it's 2 pi. So 1 pi radian is 180 degrees. You have radians here. You want to get rid of it. Put the pi on the bottom, and the pi's will cancel. You have degrees, and you want to turn it into radians. Put the pi on the top. Put 180 degrees on the bottom. The degrees will cancel. Here's how we came up with the 6 trig functions. You get your unit circle. By definition, unit circle's got a radius of 1. We scaled that out a little bit when we were doing our special triangles, but everything's got an x and a y. It makes right angles everywhere. So everything on there is a cosine comma sine. So here's our 6 trig functions, and also things like tangent is a sine over cosine. So cotangent is backwards of that. And we use these 6 trig functions to basically create this unit circle. Here is the unit circle again. It's got your degrees and your radian conversions on there. You should still know those. So these are, everything going around is sine and cosine values. Okay, so 150 degrees. Cosine's negative square root of 3 over 2. Sine is 1/2. How we came up with all those values were 2 special triangles. First one was the 30, 60, 90. Okay, across from a 30 is 1, radius of 2, 60 is square root of 3 here. And then obviously you can flip that around so that the 60 comes down in the corner. Other special triangle was the 45, 45, 90. We called that 1, 1, square root of 2. So like I said, we did change the radius here to, to pull these out a little bit to scale them with much better numbers. You put these triangles in, going all the way around your unit circle. That's how we created all those values here. So if you want to get to 150, it's here. That means the reference angle is 30. Across from a 30 is a 1, radius 2. Make sure you get your negative square root of 3 in there. We had this thing here. Obviously this is positive x's, so all 6 trig functions are positive here. We said all students take calculus. So that means sine's positive here, so also what else goes with sine? Your tangents, your cotangents down here, and cosines and secants here. Okay? All students take calculus. That'll tell you which functions are positive where. Next thing is I gave you a trig function and a value, and you have to find the quadrant, and you have to find everything else here. So I know secants are the same as cosines. So first thing I do is I go do the cosine is negative 4/5 just by flipping it. Cosines are negative anywhere in 2 and 3 because this is a negative x over here. This tells me tangents are positive. Tangents positive only in quadrant 3, so I put a triangle in there. Once I have my triangle, I take a trig function I know for sure, like a cosine. Whoops, sorry, screwed. So cosine is adjacent over hypotenuse, so make sure you get the negative in there because we are in quadrant 3. Use Pythagorean theorem to find the missing piece on your y-axis coming down this way. Once you have your triangle, you can grab every other trig function you need. Okay, everything just comes from the triangle. You may have to rationalize if there's square roots in there. Make sure you take care of your signs and everything works out from there. Last big topic was how we graphed, okay, and you will have to do some graphing. We'll keep it with easier trig functions on your final. First thing is the quadrants here. Okay, we have to label all of these points. So you label all those points there. We know every coordinate is a cosine comma sine. We use these 5 points, whether you're doing cosine or a sine graph, and we use these equations to transform them. Big thing is You have to make sure that this b down here in the equation is factored out of there. A is your amplitude, basically tells you how tall the waves are. Period is 2 pi over b. Okay, if the b is a 1, everything happens in 2 pi, like these waves here. If it's not, it changes, either stretches or shrinks it. This is your left and right shift. If it is a negative, make sure it's going to the right. So I know we only put a negative in that equation there. But if you have x minus pi over 2, you want to make sure it heads to the right pi over 2, so a minus minus. And then the d is anything with an up-down shift, and that's always the true sign. Okay, so we got that in under 6 minutes. Not bad there. We'll start looking at some review problems in class.